and on email. Next is our live course, OFM from A to Z course, which will take place in January. And this course will be 2 weeks of course theoretical and 1 week project. It will be between 35 and 40 hours of live training. And in the course days, you will get 3 hours per day for 10 days. And in the project days, you will have 1 to 2 hours per day for 5 days. There will be real case studies that you will work on and full support from instructors to answer all your questions inside the live session, but also outside the sessions if you have any questions. And of course, you will get also a certificate of completion when you finish the course. And right now we have a 25% discount. It started around 2 weeks ago, so 1 more week for the discount, 25%. So it was $250, now it's $189.99. Also, it's a great opportunity to get this course for discount for the offer ends. You can also scan this QR code for the OFM course, and my colleague will also send the link in the chat. Next is our 4x4 program, which will be delivered by Engineer Ahmed Ali, who is giving the webinar today. And basically the webinar today will be like a teaser for this 4x4 program. So if you want more details after you finish this webinar today, this is the right place you go to, which is the 4x4 program. This will be 4 hours, each day 1 hour from 27, 28, 29, 30 December. So as I said, 1 hour per day, and it's focused, fast, and effective knowledge that you will get from 10+ years experience Engineer Ahmed Ali. And it's $44.4 only for this program. So on the left side, you can see for each day, what's the focus of the session. It will be in the first day on slick line, second day electric line, third day coil tubing, and fourth day frag operation. And for this program, you can also register by scanning this QR code. You can also fill in the form in the chat that my colleague just sent right now. And basically, also, as I said, if you feel that you need more information from what will be in this webinar, the 4x4 Rigless oil intervention program is the one that's right for you. Next is our one-on-one mentorship program, which is a program tailored based on the needs of the mentee. So if you have any topic that you want a special explanation on or a special guidance, you can ask for this online mentorship, where we will basically assign you to one of our highly experienced mentors, 10+ years experience. And these mentors will help you in your problem or in explaining something to you. So you can, for example, request explaining the know-how of a software or a topic in the petroleum industry. You can also request practicing on how to produce output from a software. So for you, if you have the data, but you want also to get the best use of the data that you have, you can also ask for that. We already completed 21 mentorship programs before, and all of the mentees were highly satisfied from the outcome. So basically, the mentorship program is charged per hour, and you will get discount based on your situation. So for example, if you are a student, you will get big discount on this program. Also, if you are an ambassador with us, you will get also a huge discount in the online mentorships. So you can scan this QR code, or you can also get to us on our social media after the webinar to ask more and request a mentorship, for example. Finally, becoming an OPA ambassador. So there are 3 tracks to become an ambassador, but first, why should you become an ambassador? Because you will get a huge discounts on all courses in the future and group discounts for you and your friends when you enroll in one of our services in the future. So there are 3 tracks to become an ambassador. First track is taking 1 or more courses with us, like the OFM course that I talked about, or one of the recorded courses also. Second is taking a 4x4 programs. So it's not 4x4 programs, it's a mistake. Taking 1 4x4 program with us. So for example, if you take the Rigless well intervention with Engineer Ahmed Ali, you will become an OPA ambassador. And third, if you take also a mentorship program with us, we will become an OPA ambassador. So you can join our 110 happy ambassadors and seize this opportunity to get huge discounts on all our services in the future. Finally, just some rules for this webinar. Please keep your microphone muted and camera closed at all times to prevent any disruptions or any thing that can distract the instructor. Put your questions in the chat box and they will be answered at the end of the session. So you can write the questions that you have and they will be answered, don't worry. Use the full name in the here in the Zoom. So I can see some people are not using their full name. Please use for your full name so that we can recognize that this is you who registered in the form, so that we can give you the certificate of attendance. And note at the end, the certificates will be sent within 1 week from today. So you don't have to worry if you don't get it in the next 2 or 3 days. No need to ask us or think that we forgot you. We will send it within 1 week. Finally, thank you for listening to my presentation. And as I said, if you have any questions, any explanations, anything you want to ask about, we're always ready to hear from you on our social media or WhatsApp or email. Thank you for listening to my presentation, and back to Adel.
Thank you, Engineer Omar, for this great presentation. Now it's time for our webinar. Engineer Ahmed, the mic is yours. You shall start now.
Okay. Hello, everybody. I am Ahmed Ali, a senior well services engineer working with Shell Babetco for more than 11 years right now. We'll have today like an introduction or like an overview of what we are going to have in 4x4 program for Rigless and well intervention. I hope everybody is enjoying what we have today, so everybody can join the 4x4 later on. Well intervention or Rigless well intervention right now is one of the cheapest solutions that most of the companies are now targeting, especially for the brown fields. Because now we have in Egypt, Sudan, Libya, we have a lot of fields that is being drilled over more than like 50 or 40 years, that now most of the reservoirs are depleted, and we have a lot of wells that economically we cannot go and do workovers. We have a lot of solutions that we can do by doing a Rigless intervention, which is going to save us a lot of cost instead of doing a rig work. Also, it can add more value and production to the company. As a start, we have to understand what the well intervention is all about, and what are the types that we of the well intervention that we will go through this webinar today, inshallah. We have a Frag Operation. We'll start with slickline first. We have the slickline intervention. We have the slickline objectives and applications are so many. I don't know if somebody is working before with in the field or so, something like that, but slickline is our hands and our eyes for any start of any Rigless intervention for each well. We can go check accessibility, set plugs, test tubings. We have a lot of things. We'll talk about it later. So slick line is our first thing. We have the electric line as well. Electric line is the second most important well intervention unit that is working for us. It has a lot of capability with its signal, electric signal going through the cable. Downhole, we can do like logging, perforation, isolation, and other so many things other. After that, we will have the coil tubing, an overview on the coil tubing as well. Most of the important, one of the most important applications for the coil tubing as well is stimulation with coil tubing, lifting with nitrogen, and maybe post-frac clean out, and so many others. We'll discuss it through our 4x4 program. Last thing, we will talk about the frac operation itself. We'll just talk about the surface equipment, and we have an overlook of the surface equipment and what is a frac, how it is being done, and what is the equipment needed for the frac operation. We have other two things like pumping operation and well testing. These are not intervention, but it is surface that is being used on the wells that help and assist with a well intervention at itself as well. So we'll not discuss it in this course, but we have the other four that will be discussed during this webinar as well. First of all, slick line, we will have an overview of the slick line operation. We'll have an introduction, then we'll talk about the surface equipment that if you see here, the slick line surface equipment are composed of the unit itself, the pressure control equipment, and the bottom hole assembly that is going to go downhole. So during the course, we'll know what are the parts of the surface unit itself, what is the use of each part of this unit. Also, we'll go through the pressure control equipment parts from the stuffing box here, the lubricator, and the BOP, and we'll see the types of each one. Also, we'll see how it is working as well for each type, as we see here. This is a sample of what we're going to see during the 4x4 program. We'll start this the unit and the wire, the sheaves going up, having high pulleys up as well, with the stuffing box, then the lubricator, and going down to the well. The application of the slick line, as we know, we have a lot of applications. We run bottom hole assembly, like gauge cutters, a blind box. We have a lead impression block. We have a lot of downhole assemblies that it's been run through the wire, and do a lot of objectives downhole as well. We'll go through most of them during our course as well, because you know the slick line is one of the fastest, cheapest, and efficient unit to go and perform the job, or at least give you an overview what we have, or make an investigation on the old wells as well, to check what we have and what we can do. What are the types of wire that we are using with the Wireline? We have a single strand slick line. Also, we have multi-strand slick line, which is braided line. And the other, or the last one, is the monoconductor or multi-conductor cables. This is going to be for the electric line, which is going to be explained on the second stage. What is a slick line? A slick line is a thin steel wire that's been run in the well bore with another tools to perform many operations like depth measurements, sampling, or setting, retrieving plugs or gauges or valves. You know, we have a lot of fields that have gas lift valves or using artificial lift as a gas lift valves. These valves are installed inside bucket mandrels, and these mandrels, when we have any issue with the valves or we have a change in design, depleted wells need to be go through another design of the gas lift valve itself. We have to change the gas lift valve or the dummies or orifices which is installed in the side bucket mandrels. So we utilize slick line for such operation. We utilize slick line for checking the accessibility. We utilize a slick line if we have a pressure temperature surveys with memory gauges that we can use. Normally, what we have these sizes for a slick line, but actually most of the most common sizes are 108, 125, and 160 are the most common sizes that is being used right now. 108 and 125 are used for the normal operation, and 160 if we go for fishing. This is the one we are going to use, and all these are for the slick line itself, not the braided line. We can have a look here for the differences between the slick line, braided line, and E-line. If you see here the slick line itself, this is a mono cable, and there is no any other cable. One solid cable is being run through the pressure control equipment going downhole to the well. A braided line is multiple cables that is being wrapped or braided in different ways, in conventional ways or diaphragm. This type is used for mainly fishing operation or heavy duty operation like fishing, or if you have a heavy weight tools that can be run through the braided line. The last one is E-line or electric line. We will have the same like braided line, but we have additional conductor wires that transmit the signal, the electrical signal from the surface unit to the designed BHA downhole. We have multiple sizes for this, but for the Rigless intervention, one of the most common size is 732, and sometimes we use 932 as well. What is wireline? It's a method of introducing tools and equipment into a well with an interrupted length of wire. So the applications here, as we see, we have we use it for the logging when it is electric line. We're using for the completion, setting plugs or perforation. Also for intervention, this is our main subject for the course, like checking the access or obtaining data using gauges, checking the well integrity of the wells, and setting retrieving plugs. These are for examples. I will go through each one in details during our 4x4 program, inshallah. Here we have a look for the surface equipment. See how the unit is how the unit looks like. We can see the operator, how where is he sitting, and he's watching the tension gauge in front of him, or as known as the Martin Decker. We have the sheaves and measuring device. We'll go through each one in details during our course, inshallah. The second thing is the pressure control equipment for the slick line. Here, you know, slick line or most of the well interventions operations are being done to live wells. That means that these live wells have a shut-in pressure and or live wells, most of them. So if we have a live well and we need to intervene, we need a barriers that is being kept during the whole operation active, so there is no escape for the hydrocarbon or gases to the atmosphere and not causing us any incident or well control issue. For a slick line, these barriers are called the pressure control equipment. For slick lines, we have, as we see, the stuffing box here, which is our primary barrier, and we have the lubricator, and then the POP, which is our secondary barrier. Here, another look for the whole unit, from the unit itself, going through the pressure control equipment and the tool downhole. Here we have some examples of the downhole tools or the tool string that is being run with the slick line. We have the rope socket, which is basically the connection between the wire and the BHA downhole. This it has multiple types, but it connects through an Allen key that keeps the wire hold inside the rope socket itself, and then we can attach the other tool string to the rope socket below it. We have also like the weight bar. Weight bars are just to increase the weight and the length of the BHA, the tool string, so it can facilitate and accept the objective of what we are doing during the operation, especially if we are running in high pressure wells. We need the tool string to have a heavier weight little bit so it can go through the well, otherwise it will not go through it. Also, we have mechanical jars. These jars are using, maybe you heard about the jars during the drilling, but also we have jars in slick line itself. These used mechanically while doing slick line operation for setting plugs or retrieving plugs, or like accessing the well, gauging or drifting the wells. It is being activated mechanically by increasing speed or while pull out of hole, or increasing speed while running hole, to give like an impact action on the tool itself below it, so it can use or be utilized to perform the objective of the job itself, like running plugs or retrieving plugs or anything else. Also, we can see here we have knuckle joints. Knuckle joints are used for the deviated wells. If we have a well of like 15 degree, we can use one knuckle joint in the middle. If you have well of 30 degree, we can use 1 to 2 knuckle joints as well. We up to like 60 or 65 degree knuckle joints works properly to reduce the friction of the tool string going downhole and let it go farther in the well. As we know, with the inclination increase of the well, we will suffer that the tool string will stop in the middle due to the friction and the length of the tool string. So we need to bend the tool string itself a little bit, and this is what the knuckle joint is doing. It is making a little small angle in the tool string itself, so it will reduce the length, reduce the friction, and will let the tool string go farther in the well until reach the required depth. Okay, we can go as well and see the electric line. We'll have an overview on the electric line and what it's made of and its configuration. We will have the contents of wireline types as well. The pressure control equipment of the wireline. The tool string is being utilized with the wireline. And finally, the surface equipment with the wireline. We'll go first with the overview for wireline right now. We can have more details during the 4x4 program, inshallah. So if we see here, as we discussed earlier, we have the braided line and the slick line. And the braided line that is now is being utilized for the electric line, and will have one or more conductor with can handle the electrical signal from the surface unit to the downhole tool string, and the other way as well, so it can send an order with electric signal and receive as well the data from the tool string downhole. This is what we call the surface readout. This is the configuration of the pressure control equipment of the wireline. We have, we will talk about now about the most important. As we know, this can, while doing the Rigless well intervention, we make our rig up on the Christmas tree. We have a live well, so we can, we have to have a barriers that can hold the pressure or the hydrocarbon from the well. So these barriers are at least going to be 3 barriers while doing the Rigless well intervention or any well intervention. We have to make sure if we are doing a well intervention in a live well that we have 3 barriers, primary, secondary, and tertiary. We will talk about these barriers as well in the 4x4 program. So if you have a look here, we have the stuffing box as well in the up, with the most important thing for the electric line is the grease injection head, which really holds the pressure from the well. It consists of flow tubes or small tubes, and it has a hydraulic oil that is being pumped through it to prevent the well to flow from the upper part, from the opening of the upper part, and make sure there is no any hydrocarbon release from the tools. And continue with the envelope of the pressure control equipment. We have the lubricator. Going down to the other most important thing is the BOB. The BOB for sure for the electric line is a little bit different from the slick line. We'll go in details in our program, inshallah. But as we see here, we have like triple ram in this example. The BOB is our secondary barrier. The secondary barrier is the barrier it has, or it's a closable barrier that can be closed when the first barrier is went wrong and cannot be controlled or in a failure. So it can be closed and contain the well hydrocarbon. So we can fix the first barrier or the primary barrier. Then we can continue with the operation itself as well. Okay, normally for the slick line and E-line, we utilize the upper master valve on the Christmas tree, which is a wire cutter, as a tertiary barrier to cut the wire line in both units. So most likely or rarely to have in low profile wells to have a tertiary on the PC pressure control equipment setup. But in some high profile wells or category 3, we have to install a safety head or shear seal BOB just above the Christmas tree to provide us with another shearing capability to do the if in case that both first and second barriers has failed and we have a hydrocarbon release and we need to secure the well, so we go to the tertiary or shear or shearing BOB to cut the wire and drop it in the well. Then we can secure properly the well and close all the Christmas tree valves. Also, we are going to discuss the two strings of the electric line. We have the cable head, which is mainly same like the rope socket in the slick line before, but it's a little bit different. We'll go in details if we have time in the 4x4, that how we calculate the weak point and make the rope socket for the electric line as it is special, a little bit, not like the slick line. We have weight bars. We have gamma ray CCLs. We can run with, we have centralizers through tubing bridge plugs, a lot of downhole tool string that can be run through the electric line. As you see here, this is the surface equipment of electric line. We have the pressure testing skid and the grease injection system, plus the truck or the unit itself. We have, these are the most two important things, because the grease injection system is considered as a primary barrier as well, because it is the pump is injecting the grease or the lubricant oil that is pumped through the flow tubing in the grease injection head and prevent the well hydrocarbon from escaping to atmosphere. Also, the pressure testing skid is being utilized between runs and before and at the beginning of the rig up itself as well. So it can, it is pressure testing the whole pressure control equipment and make sure that everything is okay and there is no leak is observed through whole the PCE. Now moving to coil tubing operation, we will have an overview on the coil tubing. You know, coil tubing is one of the most complicated well intervention means that is being run into the well, and also it provide us with a lot of options, a lot of cheap solutions as well. In so many cases, it provides us with a lot of capability for intervention and solving problems downhole. If we have a look here to the coil tubing layout, we will categorize the same for the coil tubing as the two previous before. We have surface unit, we have the pressure control equipment itself. Also, we have the tool string or the PHA of the coil tubing. If you see here first, we'll see the surface equipment here consisting of control cabin, which has the lead to drive the coil tubing with power back to give all the required hydraulic power to the coil tubing unit itself and the pressure control equipment as well. And then we have the coil tubing reels, which is basically only a reel that is the coil tubing is wrapped around it, and it has no force to run the coil or pull the coil out. So we'll go after that for the injector head, which is basically the top drive of the coil tubing, which has the power of running the coil tubing in hole and pull out of hole with the coil tubing, and grip the coil tubing with a grips inside you and catch the coil tubing, preventing it from falling apart. Also, it facilitate running and pulling out of hole with the coil tube itself. After that, we will discuss the pressure control equipment of the coil tubing. Our primary barrier is in coil tubing is the stripper, which is almost like the stuffing box as we discussed before, but it is bigger size and have harder rubber inside to prevent the well from flowing as well. And this is our primary, which is being kept active during whole the operation. After that, we'll have our secondary, the VOB, which is in case of the failure of the first one, we will have to activate the BOP and keep it closed. Then fix the stripper or the stuffing box above it, and change the rubber element. After that, we can continue with the operation itself normally. Usually we have a shear ram in this BOB as well. So it provides us with a shearing capability on the well. Here we can have a look to the component, which is going to be discussed through whole the course, inshallah. We have, as we discussed before, coil tubing reel unit, injector head, power back, and control cabin. Also for the pressure control equipment, we have stuffing box, quad BOBs, shear seal BOBs, and maybe sometimes we have annular BOBs. For the coil tubing string itself, we have the connector. We have a common MHA, as it's called, or BHA for the coil tubing should be installed on each operation, and then we have the final one, which has been changed. So we have the tubing end connector. It's basically like the rope socket before, but this connects the coil tubing to the BHA. It has two types, internal and external connectors. Then to be followed by the back pressure or dual check valve. Dual flapper check valve are used as a barrier from inside the coil tubing in case if we have a crack at surface and we may have a hydrocarbon release from inside the coil tubing itself. Then we have the release joint or the hydraulic disconnect. This is being utilized if we have an unfortunate case that the coil tubing is stuck with the BHA downhole, and the stuck point is the BHA itself. So we have to disconnect the BHA which is stuck and go and pull out of hole to secure the well. So this is the hydraulic disconnect or release joint. We will talk in details, a lot of details about this, inshallah, in our program. Also, we have, these are the main component of each BHA that's been used or tool string being used with coil tubing operation. Then we can add like straight bars to increase the length of the tool string, or then we go with jet nozzles or fishing tool string, sorry, to work on the fishing downhole and get it out of the well. Last thing is frac operations. You know, frac operations is the most complicated operation in Rigless intervention and consists of so many equipment as you see here. It has a wide range area of equipment at surface. A lot of tools, pumps, iron, and high pressures. We'll not discuss the frac design or how we you select types or all. We'll just discuss the surface equipment of frac operation and how we can we will know what are these the component of this surface equipment. Also how we test, what are the measures being used for each test, so we can run the frac operation safely and efficiently without any problems to be occurred. So we will talk about the frac types, frac equipment. We'll have an overlook with the frac life cycle. As we see here, if life cycle. This video, if someone is interested in the oil field and doesn't know what is what basically is the life cycle of the well. This is where our part starts here from the life of the well. Okay, so we'll talk about the hydraulic fracture theory. Here we have the first hydraulic fracture was in 1947. Basically, it is only pumping fluid into the formation with high pressure and high rate to frac or make a fracture inside the formation itself as well. So it started this way. They just pump stimulation treatment and that's it. And then it's been developed during this later on period until it arrived to what we have right now with all the complications that we see right now. So it started so basic and now it's a little bit complicated. What is hydraulic fracture? Hydraulic fracture is a well stimulation technique involving the fracture of bedrock formation by pressurized liquid. This process involves a high pressure injection of fracking fluid, which is primarily water containing sand or propellant, which is ceramic, into a well bore to create cracks or fractures in the deep rock formation through which natural gas, petroleum, and brine will flow more freely. When the hydraulic pressure is removed from the well, small grains of hydraulic fracture propellant, either sand or aluminum oxide, holds the fractures open. So we just fracture the well by pumping frac fluid in very high pressure. This will create a fracture, small fractures into the formation. But actually, when you think this small fracture is going to be permanent, no, because when we stop pumping, the pressure will be released and the fractures is going to be closed later on. So we pump through this frac fluid. We pump sand or propellant, as mentioned, to keep these fracture closed. When the pressure is released, the sand or the propellant holds fracture from closing, and this will create a giant permeability for the hydrocarbon to flow back into the well and then to the surface. So basically, it is increasing the permeability of the formation around the well. As we see here, this is a basic layout of the Frag operation. We will talk about this in details during our 4x4 program. So we have frac tanks to collect the water to be ready for the frac fluid itself. Then we have the blender, which is the main core or the brain of the frac operation, which take the frac fluid from the tanks and mix it with other chemicals and bring propellant, which is downhole. If you see here, it's called mountain mover or sand sieve, the sand storage itself. And the blender brings all of the water, chemicals, and sand and prepare the mixture to be pumped through to be pumped to the well. Then it is pumping it with low pressure into the manifold, and the manifold then this frac fluid is being sucked from the manifold to the high pressure pumps, which are, we have here, for example, 5, 3 up and 2 down, and then repump it again with very high pressure up to 15, 20K pumps to the well, creating a fracture in the formation. So during the 4x4 program, we'll know why we have to have a backside pump, what we are using or utilizing in the wellhead to prevent the Christmas tree or the wellhead from failing, because what we have normally is 5K wellhead or 10K wellhead, but we're talking about 15K pumping pressure at surface. So how we keep our wellhead from failure, we'll talk about the wellhead isolation tool or the Christmas tree saver during our course, inshallah. So we'll have a better look about the frac equipment itself. This is simply what frac is and how it is being pumped in a very simple way as for the beginners, and we can talk a little bit in detail about the frac operation itself in our program, inshallah. So I think that's all what we have for today. If anyone have any question, I am happy to listen.
Thank you, Engineer Ahmed, for this great presentation, and we wish you a speedy recovery. And now it's time to receive all your questions. Please, if you have any question, write it on the chat box. We have a question here. What are the disadvantages of hydraulic fracturing? Is hydraulic fracturing job environment friendly?
Okay, if we are going to talk about hydraulic fracture and the environment, actually, we have certain countries that is preventing doing the hydraulic fracture. Why? If we have like the formation that we are going to break through it is close to an aquifer which has a fresh water, you cannot control actually 100% that these fractures are not going to go to the aquifers. So it's going to cause a pollution for such wells, such aquifers, and then we will lose like an asset, big asset of all each country, which is the fresh water. So a country like France is preventing hydraulic fracturing because of this, because their aquifer is close to the hydrocarbon layers. But for example, here in Egypt, our formation that is being that is producing hydrocarbons is way far from aquifers. So that's why it's depends on the situation that we have.
Okay, someone's asking if there is a difference between acidic frac and hydraulic frac.
For sure, and this is included in our 4x4 program, inshallah. Yes, there is a difference. Difference in the theory, a little bit in the theory itself, because normally acid frac is the acid frac is rely on the chemical reaction between the acid like HCl or hydrofluoric acid and the formation itself to create the wormholes inside the formation. These wormholes increase the permeability. They are relying on the wormholes to increase the permeability instead of creating fractures and setting propellant inside the formation. So this is the difference. Here it's mechanical little bit in the normal conventional way or the unconventional way, or and the other side in the acid frac, it is most likely a chemical, not mechanical. So it creates a wormhole to increase the permeability, and most likely no sand is being pumped through the acid frac.
Okay, I have another question. What types of propellant are used in hydraulic frac?
we have a wide variety of propellant to be used in hydraulic frac. We have first we categorize the propellant in so many categories. First, we have the sand, which now most of the hydraulic fraction is going to. We have the ceramic propellant. This the ceramic propellant is divided to intermediate strength propellant and bauxite, which is high strength propellant. These propellant are being utilized when there is, you have to know the stresses of the formation itself, and based on the stresses is being applied, you can design and see the type of the propellant. Then we based on the formation heterogeneity and the formation itself, we can design as well and choose the type of a propellant. But actually, our course will not go there. We're just talking about the surface equipment of the hydraulic fracturing and what is being utilized and pumped through the fracture operation itself. So it's a little bit to the petroleum engineering. And thanks.
How can we overcome or correct the depth error in coil tubing?
So the depth error in coil tubing, it has a lot of correcting methods. There is simple, cheap, and expensive. Simple, cheap, that we have the tubing end locator. It's a tool. It's been run with the tool string itself, and it locates the tubing end. Also, you know the tubing end from the beginning because you already run this completion before, so you know that the depth now is the end of tubing, so you could relate the depth. This is one method. We can run also it's called as e-coil or fiber optics inside the coil tubing. It has a gamma ray CCL and can correlate the depth as well, but it's a little bit expensive option. The surface tools, whatever you do, we can do like a mechanical measuring device, and we have like electrical measuring device on the coil tubing itself. On the coil tubing, the tube at the surface, but it has an error. It has an error. We cannot use this for like perforation operation or water shaft of operation that needs an exact depth of the to perform the operation. So it can be used like plus or minus, but to reduce the risk, these are the solutions that we have with coil tubing to correlate the depth and have a better depth measurement.
Thank you. Someone is asking, how does Wireline reach bottom in deviated well to collect data? Because many times inclination is more with more than 50 degrees, there are chances of getting stuck.
Okay, for slick line or electric line, we'll go for slick line first. Slick line, we add knuckle joints until 70 degree. Like we add like 30 knuckle joints until 70 degree. It may help if the well itself is a smooth well, and there is no sediment inside the well. There is no any precipitation from the formation itself. Okay, but more than that, we can go for like 80 degree with a roller stem. It's basically a wheel on the tool string itself. It's been run with the slick line. It helps the slick line to achieve more in the deviated, but actually it cannot go more than 75 or 80 as well, not more than that. For electric line, it can go more using roller bogey, which is like roller stem basically, but it's much better in the mechanism, or we can go for the deviated wells, or the horizontal wells, which is like 90 degree, 80, 85, something like that. We can use the tractor. The tractor is a tool string, basically is being run with the tool string itself, and it is like a car. It has wheels, and it's being controlled with a motor downhole. It's being controlled from the surface. Just send the signal, and the wheel is going to run and take the BHA with the tool string with it, and like drive inside the well until reach the required or the requested depth. So we can beat the inclination, but with more expensive tools.
Someone is asking if the 4x4 course contains design of hydraulic frag, calculation or software practice, or just based on theory or background.
4x4 is not going to discuss the design for Frac or the calculations. It's going to discuss the surface equipment and how we can run the operation safely on the surface, not theoretical. It's a practical course.
Okay. Ahmed Abdulaziz was asking, this model or method is very recommended for perforation operation, especially in multilateral and cluster wells. Can you give a little about that?
Which model, sorry?
He said that this model, I think he was quoting your answer about some question.
About the tractor. It's been utilized for the multilateral, yes. This is what we utilize if we have horizontal or multilateral. Also, if we have intelligent completion as well, we can utilize this inside it, but it's already been utilized. But here in Egypt, because we, some of the Egypt, Sudan, Libya area, Syria, this area is we don't have much of complicated downhole well design. So that's what we have. But if you are utilizing in multilateral, we utilize the tractor, we utilize all the tools that to be used there. It is basically from designing the well before drilling. We make sure that all the tools are available and can be run through the tubing and the completion through whole the life of the well. So it's being designed from the beginning when in the design phase. Okay.
How can we frac multi-layer with one pump at surface?
One pump. Okay, basically the frac operation is not being done by one pump. It is being done by multiple pumps, because each pump has its certain horsepower. It can pump a certain rate and within the pressure rating of the pump itself. So we have a lot of techniques to frac multiple layers. So we will discuss it during the 4x4, the unconventional. It has two techniques, the plug and perf and side sleeves. But normally in vertical wells, we can do bottom up frac. We'll just frac the bottom part, isolate by sand plug, and then frac the upper part. Okay, and then isolate, then frac. This is in vertical wells. If we have wells that are already perforated, like we have two perforation intervals and we just want to perforate the below part, not the upper part, we use another technique in Halliburton and Schlumberger. It's called diversion. We pump special chemicals to divert from the upper part and go directly to the below part. But it depends on the permeability and some certain values of the formation itself, and should be prepared properly before the before the design and bumping the operation. But we can do it in vertical ways. In the vertical wells, we can bump it isolation by sand plugs, or using a workover, for example, to run a temporary backer and frac each zone separately. This is a second solution. And the third solution, what I already talked about, these are in the vertical wells, the normal wells, conventional way. In the unconventional way, we have two ways. We have the plug and perf, which now is most commonly used. We'll just go after drilling the well. We in the unconventional wells, it's a monobore well. So we after drilling, we set the production casing or the liner production cases to the surface, and then we'll go with wireline, perforate, perform a frac, and then go after that with wireline, setting plugs, then perforate the upper perforation interval, and then frac, and continuous go on. Like if you have like 3, 4, 6 stages, we'll discuss about this inshallah in 4x4 program, inshallah.
Okay. The last question for today. Is there any selection criteria for surface equipment in rigless operations, specifically for crane to lift well intervention equipment?
For sure, but it depends. We have the well intervention. What we have in rigless well intervention, the crane, it is lifting mainly only the pressure control equipment itself, and keep it hold on the well during the operation, all the operation. If we have a lengthy tool string, like we are performing a fishing operation and we need like 25 meters or like 60 feet or something like that, tool string to perform the milling or fishing operation, this is gonna need a lengthy PCE with like 6-7 sections of pressure control of lubricators. So we'll have like, you will see like 50 meters on ground need to be controlled by bigger crane. Normally we utilize 30 to 50 ton crane, but for more complicated operation, we may go to 80 or 100 ton cranes if we require.
Okay, someone wants to ask a last question. Why do we cement the end of casing between float show and float collar?
Actually, this is not my specialty. This is not, I can answer, but this is not related to the well intervention. So it's not out of my lead. Sorry, I will not answer.
Thank you all for attending, and thank you, Engineer Ahmed, for this great and valuable information.
You're welcome.
Thank you. Good luck all, and don't forget to enroll in our 4x4 program. It will discuss a lot of information regarding this topic. Thank you.